These are notes number 14, the first notes for this week. It's about isosceles and equilateral triangles. So there are two special kinds of triangles, and you should already have this written down from class, but here's the essential question. How do I use and apply properties of isosceles and equilateral triangles? So you're going to learn some special properties about them, and then we'll apply them. So the proof right here should have been done during class. All right, and then here's the first part about isosceles triangles. So pause as needed. I'm going to start filling out this part about an isosceles triangle. So there's a couple different special angles. So on an isosceles triangle, we always have these two angles congruent, and they're called base angles. Those ones are base angles. And then it's probably pretty clear, but this side down here is called the base. And this one that I already marked up here is called the vertex angle. All right, so basically the way to think about it is you're going to have two angles which are congruent, so they're the same measure. Then the other angle is called the vertex angle. And then there's just a couple more things you need to know about isosceles triangles. The two legs opposite the congruent angles are also congruent. So we have two sides which are the same length and two angles which are the same measure. So we're going to call these sides legs. The ones in purple are legs, whereas the base is the bottom, and the base is across from the vertex angle. And that's pretty much all the vocab you need to know about an isosceles triangle. Okay, so then we go to the theorem, theorem 20, isosceles triangle theorem. It says if two sides of a triangle are congruent, think about right here how we have two sides that are congruent, then those angles opposite those sides are congruent. It's really just saying what I just said up here. So this is a pretty easy theorem to remember. So here it is. If a C side segment is congruent to BC, AC and BC. I drew it kind of wrong, but I'll still just mark it the way like that. So if AC is congruent to BC, then angle A is congruent to angle B, like that. Okay, so it's always the angles which are opposite from the sides, like that. So you can see how opposite from that one is A, and opposite from that one is B, whereas C, right here at C, would be the vertex angle. It's the one that's not congruent. And you can see right here, C is the one that's not congruent. So pause if you need to, otherwise I'm going to move on. And I just want to remind you, as you're writing your notes, just copy everything down like we're doing, but when you're done, you've got to go back and put questions, like 3 questions per page, that will help you kind of study and think about what is this about. So just for example, a good question that would go with theorem 20, like maybe you want to write a question right around here, you would maybe write something like, if two sides of a triangle are congruent, then what else do I know? Or you could say something like, what else do I know if two sides are congruent? And the answer, of course, is you would know two angles are congruent. Okay, and then here is theorem 21. This is the converse, which is kind of like the opposite or like backwards of the one we just did. Converse of the isosceles triangle theorem. So this one says if two angles of a triangle are congruent, then the two sides opposite those angles are congruent. It's really just saying this, but backwards. Here we had two sides congruent, then we know two angles are congruent. Here it's saying if we have angle A congruent to angle B, then we have a segment or side AC congruent to side BC. AC and BC. And I can just mark them all together just so you can really see it. So if you're given, or if you know, if it's marked or whatever, if you know that two angles are congruent, then you know the opposite sides are then congruent. It's a theorem. It's been proven. So we just know this about triangles. So another good question maybe for the bottom right here. Now I'm thinking, okay, so what's the difference between theorem 20 and 21? So you could have a question like compare and contrast, or what's the difference between theorem 20 and 21? Because it's good to make you think like, okay, so what is the difference? And again, the difference is what are you starting with on the triangle that you're given? Do they have sides that are congruent, or do they have angles that are congruent? And either way, you're coming to the same conclusion that it has like opposite angles are congruent or opposite sides that are congruent. All right, these are notes 14 continued, so I had to go to a different page. So whenever you need to go to another page, that's fine. So this side is about equilateral triangles. It is in your book, just like how on the other page I had what book number or which book page to go to. So equilateral triangles, I'm sure you've learned about in previous courses, you just kind of know it. But these are corollaries to theorems on the other page. So theorem 20 was the isosceles triangle theorem, but this is a corollary, which is kind of like an addition, like it's a little bit modified. So if a triangle is equilateral, then a triangle, so look at that's equilateral, but then here we call it equiangular. Equiangular. So equilateral has to do with the sides. Equiangular has to do with the angles. Equal sides, equal angles. Just kind of think of it like that. So here's our example. Again, pause as you need to. So it says if xy is congruent to yz is congruent to zx. So xy is here. It's congruent to yz, but they're also congruent to zx right there. That's how we would mark all three sides are congruent. So if I know one of them is like 5, then I know all three sides are 5. So whatever one side is, they're all the same. But the theorem is actually telling us that if you have 3 congruent sides, then the 3 angles are also congruent. We'd have angle x congruent to angle y, congruent to angle z. And I just want to give you guys a little side note. If you know that all 3 angles are congruent, you can take the angles all add up to 180, take 180 and divide by 3, and you get 60 degrees. So for an equilateral triangle, or equiangular, it's the same thing really, all 3 angles are 60 degrees. And if you think about it, adding them up, 60 plus 60 plus 60 is 180. So just so you know, you can think of it any of those ways. Adding up the 3 angles, it does give you 180. They all have to be equal, so they must be 60. Okay, so pause as you need to, but I'm going to move on to the other one, which is the corollary to theorem 21. Okay. And just like with the isosceles triangles, this is basically just like backwards. So let's go through it. It says if a triangle, so remember how to say this word, equiangular. Equiangular. If a triangle is equiangular, then the triangle is equilateral. So equiangular, equilateral. It is hard to remember how to say them, so just do your best. Okay, so for this one, it says, okay, so if angle x is congruent to angle y is congruent to angle z, so they're all marked congruent, we've got all of them the same, then we've got side xy is congruent to side yz is congruent to side zx. So if we're given that all angles are congruent, then we know all sides are congruent as well. Congruent means that they all equal the same. They're all the same length. Okay. So we'll do some examples in the book, and I will help you with alex.com because it's always helpful to have a help video. So this is just the one last thing I wanted you guys to write down. I kind of explained it up above, but it helps to see it again. The measures of the angles in equilateral triangles is always 60 degrees because 180 divided by 3 is 60. Okay. So just remember that that's why. Okay, so we're going to move on to bookwork, page 157 and 158, and no more than that, just that. All right, so go ahead and get your book. And this is 3-5, like I said, isosceles and equilateral triangles. And what I think is interesting to look at is the actual book explanation. So you should read through this and also notice that this is the same isosceles triangle I was drawing that we drew in the notes. So the base angles are congruent and then the opposite sides are congruent. And then the vertex angle is different and then the base again has a different measurement. So anyways, we are going to start over here with problem 1. So this is page 157. I'll write it at the top, just so you know, page 157. Okay. So we're using the isosceles triangle theorems. So again, basically, in my mind, this is what I think. If I know two sides are congruent, then I can mark the two base angles congruent. Or if I know like two base angles are congruent, maybe it's like that, I know the sides opposite are congruent. So it just depends on what you're given. So in this got it problem, it says, is angle WVS congruent to angle S? So WVS is here, that little one, and then angle S. So I want to see, is that congruent? And then is segment TR congruent to segment TS? So TR and TS, the long sides. So first of all, notice it's kind of like one big triangle, but then it has some lines drawn, and then that forms two more triangles, and then like a parallelogram kind of shape. So there's a lot of different ways to look at it, but we're looking for isosceles triangles. That's what we're focusing on. So what I'm noticing with this little triangle is that it has the sides marked congruent. When the sides are marked congruent, I can mark the opposite angles congruent. So this one at V and that one at S are congruent. And that actually answers that first question. That is a yes, because it's an isosceles triangle. If the two sides are congruent, then the two base angles are congruent. Then the other question is saying, is segment TR congruent to segment TS? So let me see about TR and TS. So what I'm noticing is for TR and TS, their base angles are actually the same. They already had a little mark at R that at R it was congruent to WVS. Now I know that S is congruent. So in this big triangle, look at its base angles. It actually has congruent base angles. So I can just mark that the sides, it's kind of weird to mark it like this, but yeah, TR is congruent to TS. So yes for that one too. All right, so now we're moving on to the next page. This is page 158. Remember that you'll have to include these pictures at the end of the week when you turn in notes. So this one is having us complete each statement with congruency statements. Explain why it is true. So just a quick explanation like isosceles triangle theorem or converse of the isosceles triangle theorem. All right, so let's take a look at this triangle. So it says VT. Side VT is congruent to what side? So VT is here. So I can see the base angles are marked. So I do know that side VT is congruent to side VX. And so this is the one where it starts off with congruent base angles, which is the converse. So I'm just looking back in the book, but you could also look in the notes. This is the converse to isosceles triangle theorem. Converse to isosceles triangle theorem. All right, and then the next one, it's saying that side UT is congruent to what side, which is congruent to side YX. So side UT is here, and then YX is right here, okay. So it's actually giving that to me that they're congruent. And so you have to find what other side is congruent. So I'm thinking it's going to be this side, UW. I just have to have a reason. And the reason is if I mark UT congruent like right here, I see they do match. But then the other thing is they do have the base angles congruent already. So across from the two base angles, the sides would be congruent. So there's like two reasons there. But I'm going to say, since this is the isosceles triangle section, I'm going to use that reason. What is that? UW. And so again, the base angles were marked congruent, which would be the converse. The one that's not the converse, the isosceles triangle theorem, starts with the sides. So converse to isosceles triangle theorem. Okay. And next one. So now we've got side VU. So I'm going to look and try to find VU. That's this one. So I have to try to see which side is congruent to VU. All right, so looking at our triangle, VU is here. I'm noticing that this other part of that line is congruent to this other part. And so you can tell the answer would be VY. We just have to come up with our reason. So this one is a little complicated, so make sure you follow along with me. First, we said that segment VT is congruent to segment VX, so that's the long side, and that's because it's an isosceles triangle. And now we have that those three segments are congruent, so this one here and this one here. So you know that these would be congruent, the VU and the VY, and the reason is because it's not really an isosceles triangle thing, it's the, looking at the list, it's the segment addition postulate, because we know that if the two, if we have the whole segment and then you take out a part, whatever's left would be the same in another like congruent segment. If you take apart a way that's congruent, it would still be the same little tiny segment left for the two. So it's the segment addition postulate. Okay. And I'm going to mark that also. So it's this side and that side. And then that leads us to, I thought that we were going to come to this one. So angle VYU, VYU is this one. And you can tell that VUY is already marked with the one mark, the one arc. Okay, so I know that it's going to be VYU and VU, angle VUY. VUY. Yeah, I'm going to mark those. And then let's look at it and see why. So going from number 3 to number 4, I did just mark that those sides are congruent. Therefore, this top part is an isosceles triangle. And that actually is the isosceles triangle theorem. The isosceles triangle theorem is this one where you have the two sides marked congruent and then the opposite angles are congruent. The base angles are congruent too. Okay, so that is it for the bookwork. We didn't get to, oh, whoops, sorry. We didn't get to the equilateral triangles or equiangular, but they will be in our ALEKS assignment. So it is very, very important that you watch the ALEKS number 14 homework help video, which you do not need to take notes on, but watch it and it will help you to complete your assignment and to learn this a little bit better. Make sure you have your 3 questions per side on your notes and also a 3-sentence summary so that you can get full credit when you do turn in your notes.